Good evening, one and all. I am Sharda Lakshman from Teachers Couple Talks channel. From few days I was explaining about the concepts of science, about excretion, digestion, reproduction and systems in various organisms, about the organ system of organisms from lower to higher. And I am thankful and grateful for your I'm glad to receive your thanks, and I am also glad for teaching. I am glad to teach these aspects of science. Next, please share my channel, subscribe my channel, and like my channel. Let us getting into the topic. Foremost thing is, today is chemistry topic, and the chemistry topic is the types of reactions of acids and bases. Let us know what about acid and bases. Acids are the substances, solutions which are sour in taste and pH level is below 7, and they are indicated when they are tested with litmus paper. They turn blue litmus into red litmus. Next, again bases. What are the properties of bases? The bases are so bitter in taste. They turn red litmus to blue litmus, and their pH maintained below 8, above 8. Then how we can identify an acid and a base? We can identify acid and base through some indicators. What are those indicators? The indicators are of two types. They are natural and artificial. What is natural indicators? The natural indicators are litmus paper and red cabbage and China rose petal. Next, what are natural fibers? Natural fibers are artificial fibers are methyl orange and methyl red. Next, what is how we can know about the indicators are these, and what is neutralization? When acids and base are mixed, the ions are balanced into water and they are diluted, and so this is called neutralization. Then what are the types of reactions, and how many types of reactions are there? There are 4 types of reactions. The first type of reaction is chemical mass of conservation. When potassium iodide and lead nitrate solution, for example, what is about the reaction? The process, the materials are potassium lead nitrate, potassium iodide, conical flask, test tube, and that's all. Conical flask and test tube. Then procedure. What is the procedure? Take a pinch of lead nitrate solution in a test tube and add some dilute water to prepare the solution. Now take a pinch of potassium iodide and add some distilled water and diluted water. Then this becomes potassium iodide solution. Pour this potassium iodide solution in a conical flask and pour lead nitrate solution into the conical flask. Now reaction. What does it form? First weigh the substances of solution before reaction and after reaction. Let us conclude that the weight of lead nitrate solution and weight of potassium iodide solution be weight 1 and weight 1 and weight 1 of lead nitrate solution, potassium iodide solution. Next, measure after reaction about the mass of lead nitrate solution and potassium iodide solution. We can clearly know that yellow precipitate is formed. In this reaction we can see there is no conservation, the mass of conservation of chemicals. How we can say means the after and reaction, before the reaction and after the reaction the solutions remain same in weight. This is called law of mass of conservation. Next law, chemical reaction of combustion. When we burnt a magnesium ribbon, what are the requirements? Magnesium ribbon and test tube burner or spirit lamp and some dilute water. Next, first let the magnesium ribbon burnt with the splinter. This forms as ash. This ash is formed into magnesium oxide. Dip a red litmus paper into it. We can see the formation of magnesium oxide in the ash. When we dip a red litmus paper, it turns into blue litmus. This because of mixing the magnesium with oxygen in the air of atmosphere. This is called magnesium oxide solution. Next, this is called chemical reaction of combustion, and we can know that this is called thermal combustion also. And next, chemical reaction of combustion after chemical reaction of decomposition. What is decomposition? When we add what are the materials for it? Calcium carbonate, limestone, spirit lamp, and diluted water, and a matchbox. These are the requirements. We can add a pinch of calcium carbonate solution to make solution distilled water. Then add some. Take a test tube and pour some limestone. But take a test tube and pour some limestone. When we take this calcium carbonate solution in the test tube and burn over flame of spirit lamp, then introduce a matchstick inside the mouth of test tube, which when the limestone is poured. This is called decomposition. How we can see? Calcium hydrocarbonate reacts with calcium hydroxide, that is limestone, and liberates carbon dioxide. Then the matchstick lights with the fire. Then after this is called chemical decomposition. This carbon dioxide outcoming can be seen with the lightning of a matchstick. Then this is called thermal reaction. And next next reaction is chemical displacement. What is chemical displacement? The replacement of one chemical with another chemical is called the replacement of chemical reaction. This is called displacement. What are the requirements? Zinc dust soil paper and conical flask. Not conical flask, it's a test tube and a spirit lamp. Add dilute water to some zinc dust taken in a test tube. Then add some hydrochloride diluted solution into this zinc dust, and then burn this over a spirit lamp. No, not burning. Then what happens means the reaction between zinc dust and hydrochloric acid reacts and it forms zinc chloride and hydrogen is liberated. Now when we put before reaction, we have to close the mouth of the test tube with the balloon, and this is due to this the balloon bulges, and the hydrogen, due to entrance of hydrogen gas into the balloon, this is called chemical displacement. How does it, what has happened means zinc mixes with chlorine and forms zinc chloride and liberating hydrogen gas. Due to liberation of hydrogen gas from the test tube, the balloon bulges. Thank you one and all. Today's our topic is ended, and I am thankful and grateful for all the viewers who are sharing my channel, subscribing my channel and liking my channel. Thank you one and all.